Well, hey, hi everybody, and welcome to today's webinar. My name is Marina Skumanich. I'm a program specialist at NIDIS and coordinator for the National Coordinated Soil Moisture Monitoring Network, and I will be moderating today. Really happy to have you all with us. This is part of an ongoing seminar series we have at the National Coordinated Soil Moisture Monitoring Network, which is intended to provide an ongoing opportunity to hear about active areas of research and exciting projects like the ones we're going to hear about today. If you have any project or research you would like to share in this venue, please send me an email. I'll put my email in the chat box. And today's seminar, again, really excited to be part of this, will be a discussion of water resource applications of soil moisture, case studies from the Colorado River Basin. When we set out to do this presentation, we weren't actually considering focusing on the Colorado River, but it's just a lovely situation. We've got two really interesting projects in this area that are not federally sponsored, not state sponsored, but actually nonprofit or smaller group sponsors, which we think there will be more and more of those over time. Next, oops, okay, I'm moving my own slides. All right, so just really quick on the National Coordinated Soil Moisture Monitoring Network. If those of you have not heard about it, I'm surprised. We try to make sure we communicate it pretty broadly. This is our effort to build, our being a multi-institutional, federal, state, private effort to build a coordinated, high-quality, nationwide soil moisture information system to support public good processes, drought, flooding, obviously water resource management, fire, et cetera, the full range of applications that soil moisture can inform. And the three areas that we focus on to achieve our mission is building a network of networks, so taking the state, federal, and other networks around the country and having us coordinated as we can, and then bringing in satellite and model data to create the biggest picture of soil moisture conditions around the country. We also build a network of people like you, those providing data, those using that data to do research, those taking the research results and building maps, and those of you on the ground who have to make decisions, wanting to know what's going on with soil moisture and how can it make a difference for your decisions. And then finally, we focus on research and development to build the kind of cutting edge tools and maps that will really deliver information. This webinar is also being sponsored by the NIDIS Intermountain West Dues, which many of you I hope know about. It's a network of regional and national partners that share information and coordinate actions to help communities in the region cope with drought. There are 5 states and 60 federally recognized tribes in the IMW dues. They're listed there: Arizona, Colorado, New Mexico, Utah, and Wyoming. And of course, all of these states are involved with the Colorado River Basin, so clearly topical overlap. The IMW dues aims to provide the most up-to-date drought and climate information and to connect climate service providers to research managers and resource managers with one another to increase landscape and community resilience in current and future drought. So if you want, you can scan that QR code to sign up for IMW webinars and drought status updates, or you can contact Gretel Paulingstad, who is the IMW dues coordinator, and all. Let me provide a link to the website in the chat. Okay, just really quick before we get into the webinar, I just wanted to mention a couple news items of soil moisture relevant to this seminar. First, the annual National Soil Moisture Workshop's coming up July 15th through the 18th at Utah State University, again, right there in the Colorado River Basin. Would love to have you all join us for that. That's a place where researchers and those involved in soil moisture data applications come together to find out what's the latest, again, news in research and what are the issues we're grappling with in terms of our efforts to build this broader initiative. So really would welcome you to that. I'll put a link in the chat to some information about that workshop. Also, wanted to just take a moment and to announce, for those who don't know, Colorado, the various state and other agencies within Colorado and organizations within Colorado have been organizing this Colorado Open Soil Moisture Infrastructure Monitoring Project. So it's a statewide effort to build a statewide soil moisture network, pulling together in much the same way as our national initiative, the various individual efforts like the two you'll hear about today, so that together the sum of the whole can be more than the sum of the parts. And they are specifically targeting water supply and other applications. So that's a really exciting activity, and they just learned they received 1.45 million to kickstart this effort. So congratulations to the Colorado Open Soil Moisture Infrastructure Monitor Project. You're getting started now. It's great to see. And finally, we also have a listserv for the NCSMMN, and unlike Gretel, I wasn't organized to get enough to get a QR code in, but I will put a link to that listserv in the chat, and there too, if you are interested in, there's in the Mountain West first, and here's the listserv. If you're interested in news about soil moisture across the country, please join our listserv. We do not post a lot of, we won't get a lot of email. Okay, to return and focus now on the seminar ahead. This is water resource applications of soil moisture case studies from the Colorado River headwaters. As I said, we're really excited to have this presentation today because we feel like it's this smaller scale, very focused effort to work with communities and build this collaborative set of resources, soil moisture and other, obviously other environmental information as well, to inform local and broader decision making. We've got two presentations, one on the IRON network that's in the Roaring Fork Valley of the Colorado River, and then the other on the Yampa Basin. Again, both tributaries, headwater tributaries of the Colorado River, as I think probably most of you know. So Elisa Onsega will speak first. She is the Community Science Manager at Aspen Global Change Institute. She has worked there since 2013, where she manages their long-term research program, this Roaring Fork Observational Network, IRON. And her favorite parts of their job are field work, working with interns, and getting to participate in discussions relevant to the local community. And then we'll turn to YBASIN, which is Yampa Basin project. Elle Knapp is the Field Operations Manager for the Center for Western Water and Weather Extremes. Oops, I got that wrong. Western Weather and Water Extremes. She manages a land-based field research program for the center, including the center's large soil moisture network. And she'll be joined too with Madison Muxworthy, who is the Soil Moisture, Water, and Snow Program Manager at Yampa Valley Sustainability Council. And in her current position, she works to provide actionable ways that the community can adapt to a changing water supply in the Yampa Valley and increase water resilience in the natural environment. So I'll put links to both of those projects in the chat. And then at this point, I'm going to turn it over to Elise. I'm really excited to hear.
Great. All right, well, I'll keep going then. So I'm going to cover today a little bit of a broad overview about how our network was started, our community engagement program, and wrap up with a couple findings from our most recent research in terms of water resource applications. Before I begin, though, I do want to share a little bit of information about the Aspen Global Change Institute, because as Marina alluded to earlier, we're maybe not the typical group to be hosting a long-term research program. We are a nonprofit with a mission of advancing global change science and solutions in service of society. And most of our projects look a little bit different than this one. We connect researchers across disciplines. We connect scientists to stakeholders who are interested in timely questions and vice versa. But we also work to address gaps in the knowledge itself when it comes to climate change and global change issues. And the Roaring Fork Observation Network actually fits into all three of those categories pretty well. This is our long-term mountain research program. It was started in 2012 to advance understanding of mountain hydrology and ecology. And we realized since we were starting this sort of from scratch in a lot of ways, that meant we had an opportunity to go about it the way we wanted to. So we saw it as an opportunity to also be a community building effort to help continue making connections both across research groups, across watersheds, and between researchers in the local community. And we also wanted to make sure, as we were determining our research directions, that we were going in a way that was going to answer questions that our resource managers had as they were dealing with a changing climate. And that last point is really important because the local community has been a part of this program since day -1. In 2012, we hosted a workshop here in the Roaring Fork watershed looking at how do you monitor and understand forest health. And again, soil moisture kept coming up as this really important variable. But at that time in the watershed, if you weren't in agriculture, no one was looking at soil moisture. And so a city, a county, and a nonprofit up here said, if we provided funding for the initial sensors, would you guys put in a couple stations? Would AGCI start measuring soil moisture so we can see what's happening over time? And we said, sure, why not? Since then, our engagement with the community has actually only deepened. They've been essential in everything from site permitting and site access to helping with educational opportunities with the local community college, to providing individual expertise on things like vegetation surveys, to providing funding for the network, and also to having real intense conversations with us about what are they dealing with and what's the type of information they want. So with this local support, our network has now grown quite a bit. This is the Roaring Fork watershed. We're this kidney bean-shaped basin in the Colorado River Basin. And we are a major headwaters for the Colorado River. Our land area is a lot smaller than our impact. So we are about 10 times the impact on the water supply of the Colorado River of our area of land for the Colorado River Basin. So we're contributing a lot of water. And when we were expanding the network, we wanted to make sure that we were capturing kind of all areas of this watershed, not just specific subcatchments. So down at Glenwood Springs, that's the outpouring for our basin. That's where it meets up with the Colorado River. Independence Pass is up by the Continental Divide. And as we got money for more stations, we tried to kind of span that whole elevational gradient. It's also a really ecologically diverse area, and we wanted to make sure we were capturing that too. So as we picked locations for our sites, we wanted to make sure that the ecosystems and the landscapes were representative of common ecosystems and landscapes for this area. Regardless of where our sites are located, we're measuring more or less the same thing at all of them. We have soil moisture measurements at 2, 8, and 20-inch depths, air temperature and relative humidity, a tipping bucket rain gauge, soil temperature at an 8-inch depth, and most of our sites now additionally have snow depth. They all collect data every 20 minutes if they have a cellular connection, every 60 minutes if they have a satellite connection. So these are the metrics we're looking at, and the question then might be, all right, what does that mean for the local community? Why are those the metrics you're looking at? So over the 10 years plus that I have been working on this network, I've heard a lot of different questions from the local community. And this is just a small sampling of that. So they range from questions like, how is climate change going to impact my restoration activities? To, will drying impact acorn crops and bear behaviors? To, what time of year can I start looking at soil moisture to think about next year's runoff? Or how does soil moisture impact runoff from snowpack? And you might notice that those 3 questions on the right-hand side of the slide are all really similar. And these are all questions that started springing up in the last 5 years or so. So there's actually a really good reason for this obsession with the soil moisture runoff relationship. In the Roaring Fork watershed, well over half of the water in our basin comes from snowpack every single year. And for these snowpack-driven hydrologic systems, what your soil conditions are heading into winter makes a difference in terms of how much water that soil is going to take up when the snow melts in the spring. And it's important too that we are able to guess how much runoff we're going to have well in advance, because reservoir managers have to time their operations before runoff season actually starts. So to give you an example, up in this area in the mountains, typically around April 1st is near peak snowpack, and the Colorado River Basin Forecast Center at that time looks at snowpack and some other variables and runs their models and gives an estimate for what they think runoff is going to be that year. And at that same time, that same month, April, is when reservoir managers start deciding how much water they're going to be releasing. Because if they wait until runoff season and there's a huge runoff, it might turn out they didn't release enough and all of a sudden they're dumping water and flooding everybody downstream just so the dams don't break. Or they maybe are expecting a bigger runoff season than they get and they release way too much water and all of a sudden the reservoir is nowhere near full and they're trying to meet needs. And for a headwaters basin like this, what that means in the Western US is you're not just meeting needs locally, you have a legal obligation to meet calls all the way down on the Colorado River. So it's very important that you make sure you have enough water to meet those needs. And this challenge between forecasted and actual runoff is something that played out in real time in 2021. So in the 2021 water year in Western Colorado, close to that April 1st date that's so commonly used, snowpack was fairly close to 100% of average. It wasn't quite there, but it wasn't too bad. Our basin is located in the Colorado River Headwaters is where we're at. So we're in that 91% area. But when streamflow came around at the end of June, we're middle of runoff season, things should be looking great. Streamflows were only around 54% of average. And the forecast had forecasted more water than that. And this was true throughout the summer, and it put a lot of different water managers and a lot of different stakeholders in a really difficult position. So it started this question, where did the water go? And that's a question that has a lot of different answers. It probably relates to things like where the stations used to get those snowpack averages are located, whether or not we get any additional snow after April 1st, what temperatures were like. But soil moisture was also brought up as a variable in understanding where did the water go. And that was a variable that the local community really picked up on. All of a sudden, soil moisture became this buzzword in the water community in Western Colorado. So in all this context, AGCI received funding from the Colorado River District and the Colorado Water Conservation Board to start looking into that question from the perspective of in situ stations. Could stations like ours that were not necessarily installed specifically for this purpose help us to understand soil moisture in relation to how it might impact runoff the following year? And we were looking at runoff efficiency, which is essentially the amount of water in your snowpack that actually is going to make it to your streams. So I'm going to just share two findings quickly. We're in the middle of this project right now. There's a lot we're still digging into, but I wanted to give you a glimpse of what we were finding. So I'm framing this in terms of questions that I actually received from local stakeholders. So one of them is basically, how soon can I start looking at soils if I want to know what next year's runoff is going to look like? And in the forecasting community for streamflow, November is the time they typically use. And sometimes it's an average of soil moisture across a week of November. Sometimes it's modeled and they're using a single day as their proxy for what soil conditions are going to be like when the snow starts to melt. Because typically if you have persistent snowpack, your soil moisture is pretty stable across winter. So what you're looking at with these graphs is we took 4 different metrics across the month of November to see, does it matter what time of month you look at soil moisture? So we looked at each individual week average soil moisture, and then we took each 2-week period, so the first 2 weeks, the middle 2 weeks, and the last 2 weeks of November, and then we took an average for the month as a whole. So if you look for a single year on these graphs and it looks like there's just one dot there, what that means is it does not matter what time of year you looked at November soil moisture for that site, it's pretty much the same. If it looks more like a broom and you're seeing spread between the dots, that means your soil moisture average for the first week of November might have been very different than later in the month or the month as a whole. And typically what we suspect is the case for when you see that spread is that either there was a precipitation event of rain or there was some snow that melted out, so you had a warming event. And you can see, depending on some years, it may or may not matter what time of month you looked at. We went ahead and used the November average as a whole for answering our next question, which is, what is the relationship between runoff efficiency and soil moisture? And we did this for both our 8-inch depth and our 20-inch depth, and we got pretty similar results. And we did this for 7 of our sites. One of our sites is near an irrigated field, so that wasn't really valid data for this test. And unfortunately, our 2 highest elevation sites just didn't have a long enough data record to be robust for this test. But with what we did run, we were actually really surprised by our results. I went into this thinking that our higher elevation sites would have this strong relationship to runoff efficiency and our lower elevation sites would not. And that really wasn't what we found at all. So the R-squared values are that correlation coefficient between runoff efficiency and soil moisture for the month of November. And for 5 of our 7 sites, there was almost no relationship. R-squared values were between 0.26 and 0.02. Really, it was just a scatter plot. However, for 2 of our sites, we did have a pretty decent relationship. That's Glenwood Springs and Sky Mountain. They are the darker markers on this map. And I'd be very curious during the Q&A if anybody has some theories about why some sites might be performing better than others. Two tidbits I will share is Glenwood Springs was a shocker to me. That site is our lower elevation site. It's at 6,000 feet and our snow melts out and builds up repeatedly throughout the winter. So I thought using November would have no relationship whatsoever. But in fact, it did have this pretty decent relationship. And I wonder a little bit if that's because it was located near the stream gauge that we were using for our stream flows, which is the Roaring Fork at Glenwood Springs. So geographically, it was closest to that outflow point. As far as Sky Mountain goes, it's a nice loam soil. It typically behaves the way you think a soil is going to behave. And it's also our longest running station. We have 12 plus years of data from that site. So I'm very curious to see, as we have a longer data record, if that contributes to whether or not we see this relationship. However, there is a chance that it's not a matter of just data record or location. So there was a paper that came out last year that I highly recommend if you haven't checked it out, from Peter Goebel and Russ Schumacher, that looked at modeled root zone soil moisture in comparison to runoff. So what they were doing is they were looking at forecast skill. If you add in soil moisture and groundwater data, do you see forecasts that are a better match with actual runoff? And they ran this from 1981 to 2021, and they also tested some other variables that I'm not going to go into right now. But they found that for the period of 1981 to 2021, on average, adding root zone soil moisture and groundwater data did not significantly improve their forecast skill, which again was a surprise to me. I went into this study and this project really expecting there was going to be a very strong relationship. However, there were 2 years that were exceptions, 2020 and 2021. And those years, the forecast skill was improved by inclusion of soil moisture and groundwater data. And this brings up a really interesting question that I'd love to hear more from the community on, which is, are these 2 years outliers? Is it chance? Or is this an indicator of a threshold? Because 2020 and 2021 were both extreme dry years. Those antecedent soil moisture conditions in Western Colorado going into winter were the driest on record. So it is quite possible that this maybe indicates a tipping point. However, overall, one of the points that came out of this paper is a point that also is what I'm going to be communicating to my stakeholders about the data analysis we did. Namely, this idea that soil moisture is the major driver between why there was a mismatch between forecasted and actual runoff in 2021 is a little bit of a misconception. It seems like that relationship between soil moisture and projected runoff is a lot more complicated than maybe we originally supposed. And this might seem like an unexciting result, but this is the type of thing my stakeholders really want to know. They want to know, is this somewhere I should be focusing a lot of attention or not, or only focusing on it in certain years? So even having a result like this that says maybe it's not as important as we thought it was in some years is something that's really helpful to them. We still have a lot of further investigating to do. Not only do we want to dig into questions around some of the nuances to that relationship, we also are hoping to get grant funding to unpack a little bit more how representative our single point sites are in comparison to the broader watershed. As I'm sure probably everyone on this call is aware of, soil moisture is extremely heterogeneous. And so we're hoping to spend some time going more in depth in comparing our own data to model data. We're looking forward to cross-validating with the cosmic ray neutron sensors that the USGS put in last year. We're really excited about that. That's a big deal that they're working here now. And we, of course, want to continue to see what's found in the Yampa Basin, who you'll hear from in just a little bit here. And then last but not least, stakeholder engagement, of course, continues to be essential to this project. So to sum up this presentation and review, there's actually a lot of applications for soil moisture data sets that are of interest to various groups outside of the agricultural community. And I've just shared a few very small examples of how that can work and what that can look like, but there's a lot of opportunity out there. And if you want to frame those research questions around community engagement, that's something that can really enrich a research program and help make your perspective have a lot more context. But it's also a multi-year process, and it requires on really genuinely investing time, not just occasionally sending out a survey or showing up. The deeper those relationships are, the more you'll get out of them. So on that note, I'd like to wrap up by saying thank you to our 2024 partners and collaborators with whom this network would quite simply not exist. And I would also like to just say thank you to a couple of my colleagues who aren't on the call this day, Tanya Pitak, Asa Dahan, and Julie Vano, who've been closely involved in the graphs you saw and in this project as a whole. And thank you to all of you for your time.
Great, thank you so much, Elise. That's really interesting work, and obviously we're very accepting of the fact that sometimes we don't have a nail, so we don't use the hammer, or we put the hammer in the context of all the other tools. So anyway, just wonderful research. For the audience, we're going to actually hold questions until the end, so we'll move into our next presenter. But while I'm doing that, let me just mention on GoToMeeting, if you're not familiar with it, go ahead and if you have questions, put it in the chat, and then we'll get, or excuse me, not the chat, the question box, and we'll get that to you when we're done with our next presentation. So I'm going to move on to our next presenter, Al Knapp and Madison Muxworthy on the YBASIN. Okay, great. I see it up, so I think you guys are ready to roll.
Awesome. Thanks, Marina, and for the entire NIDIS team for putting this webinar together and for having us. So my name's Al Knapp. I work for the Center for Western Weather and Water Extremes, which is quite a mouthful. And I'm going to be presenting this work with Maddie Muxworthy, who's at the Yampa Valley Sustainability Council. So we are just 2 members of a very large project team. There's a lot of different collaborators and stakeholders that are really vital and necessary to have this project work. So this is CW3E and YBASIN, as well as Colorado Mountain College as sort of the primary executors of this work, but we also have a suite of other project partners and stakeholders that make this project happen. So the YBASIN network is the Yampa Basin Atmospheric and Soil Moisture Integrated Network. So we're going to talk today a little bit about the history of this project, as well as some of the ongoing work that we're doing. So soil and water resources. Recent studies have highlighted the relationship between antecedent soil moisture conditions and stream runoff and precipitation dominated watersheds. So on the right here, I have an example figure from a study in Northern California that shows soil moisture conditions at a CW3E soil moisture station and runoff from a nearby CW3E stream gauge. So on the left, on the x-axis here, we have the antecedent, so prior to the precipitation event, volumetric water content. So on the left side, this is sort of drier antecedent soil moisture conditions, and then on the right, this would be more saturated soil moisture conditions. And then we have that plotted against runoff coefficient at the nearby stream gauge. So not a lot of runoff and a lot of runoff occurring here. So you can see that when the soils are saturated and dry in the sort of left-hand corner, they behave more like a sponge and absorb the incoming precipitation, and that leads to less runoff and thus less available water in our reservoirs. However, when the soils are more saturated, we tend to see a higher runoff coefficient. So those soils are not absorbing that precipitation, and it's just running off and flowing into our streams and reservoirs. But this begs the question on how are soils influencing runoff in snow-dominated environments? And Elise just talked a little bit about their recent findings, but we've also seen that the previously used inflow indicators for reservoirs are becoming less and less correlated with observed runoff. So our project partners at the Upper Yampa Water Conservancy District, who manage the water at Stagecoach Reservoir, have noted that historically they have used snow water equivalent observations, specifically at 2 snow-tail sites, to predict inflow and make water management decisions. But in more recent years, they've been finding that these sites are starting to not be as consistent of an indicator of seasonal runoff. So in water year 2021, which Elise has already sort of talked about, the Yampa Basin in particular had an average snowpack of 89% of median, which is a good amount of snow, but it only produced stream flows that were 30% of normal. So there's a huge discrepancy here between, their previous indicators and the produced stream flow. And On the right here, I have an example of some modeling done in the upper Yampa Basin showing snow water equivalent against the average runoff. Runoff on the bottom and average snow water equivalent right around April 31st here. And we have plotted the entire record from 1916 to 2021 here. And in more recent years, we're seeing just a little bit of a decrease in the correlation coefficient between these two variables. So one possible cause is a greater soil moisture deficit at the start of the snow accumulation season. So those higher summer and fall temperatures lead to drier soils at the beginning of the season. And then combined with some earlier snowmelt, this can lead to the soils absorbing more of the snowpack and reducing the runoff into the streams and reservoirs. However, in order to study this, if this greater soil moisture deficit is contributing to the increasing uncertainty in those runoff forecasts, we do need a network of observations. So the Center for Western Weather and Water Extremes is a climate and water group at Scripps Institution of Oceanography at UC San Diego. We work really closely with other universities and colleges, as well as federal and state agencies and nonprofits like YBASIN. So being a research group at a university allows us to marry new research with operations. So we can apply that new research and science we are performing and directly apply it to water resource operations and update forecasts in real time. At present, CW3E has a network of 43 soil moisture and soil temperature stations across the West. Majority of these stations have measurements at 6 depths, and all the data, majority of the data is available in near real time. So these observations support a variety of different projects and purposes, including research, operations and applications, and decision support tools for water managers, as well as situational awareness for the public. Some of our stations have been running for 20 plus years, so we have a great period of record at those. But more recently, we've begun to work in the upper Yampa Basin of the Colorado. So CW3E initiated and co-developed with the project partners the Yampa Basin Rendezvous, which is a climate and weather and water focused event that's currently in its 7th year. So this collaborative effort includes working with the Colorado Mountain College, the Steamboat Ski Area, local water managers, and local climate and water nonprofits such as YBASIN, as well as other organizations like the Friends of the Yampa. So the great benefit of this event is that it brings together science experts and water managers, as well as the community and agricultural community within the Yampa Basin to discuss specific climate and water issues pertaining to the watershed. So this event also includes a MetTech summit. So it's a meteorological technical workshop every year as well, where we bring together different organizations that are operating soil moisture networks to discuss best practices and share ideas and knowledge, as well as determine areas of collaboration. So the Yampa Basin Rendezvous has been going on since 2018, and this event is actually what sparked the initial conversations and discussions about developing a network of soil moisture observations within the basin and to increase the sort of monitoring of hydroclimate variables. So this is the start of the YBASIN project.
And then here we are showing a map of the Yampa River Basin where this project is located. Elle just showed a map of the entire Western US, and then you could see on the right side of her screen the Yampa River Basin. And so you'll see it on this slide as well. And for those who may not be familiar with this basin, it's a snowmelt dominated watershed in Northwest Colorado. It is the largest tributary to the Green River, which is then the largest tributary to the Colorado River. So very important for the West water resources. And the basin spans elevations from lower than 6,000 feet through greater than 12,000 feet. And the land covers include heavily forested areas, like up above where you'll see Yampa on the map and Steamboat Springs. Those are the headwaters regions of our watershed. And then you have more of a sagebrush vegetation down in the valley towards Craig. And so The Yampa is also unique in that it's not impeded by major dams or trans-mountain diversions like most other headwater basins in Colorado are. And so we're a bit unique in that way. And because we're a snowmelt dominated headwaters area, we're in large part at the whim of our hydrology. And so having a comprehensive monitoring network throughout our watershed really provides us with more critical data for water and land use decision making. And then next slide. I wanted to just introduce the organization that I work for, which is the Yampa Valley Sustainability Council. We serve as one of the local project partners along with Colorado Mountain College. And our organization sees extreme value in this project's ability to bring forward relevant climate science in the Yampa Valley. And I work in the resilient land and water priority area for our organization, and we're really seeking to build climate resilience through land and water conservation and management actions here locally. And I think that a unique attribute that we bring as a project partner is providing that connection piece between this really cutting edge science that's going on and communicating it to the public. And we feel that this project demonstrates the value of establishing programs like these that bring together unique partners to create these science-driven projects. And then they generate usable data for practitioners. And as a community-facing organization, we really strive to communicate the ways in which we're experiencing firsthand a less predictable water supply here in the Yampa River Basin. And so we've already seen things like administrative calls on the Yampa River, over appropriation designation by the Colorado Division of Water Resources, along with various reaches of the Yampa River being listed on the state's 303D list for impaired water bodies due to high river temperatures, aridification, and many other things. And all of this is particularly stressing for a basin that derives most of our stream flow from our snowpack. So we really need to have a good understanding of these conditions, and it further underlines the need for more integrated and coordinated real-time observations to plan and predict our future water supply. And then on the next slide, you will see our goal of our project listed there, which is to provide data and scientific insight on the reduction of runoff by dry soils and to support operational model and forecast improvements to decision making. We launched this project in 2021 with our project partners to fulfill that goal, and we are really highlighting that we're trying to fill data gaps with this network. And so we are also assisting other partners, which we'll talk about a little bit later on, to enhance pre-existing monitoring that was going on in the basin already. Soil moisture was a relatively under-measured climate variable in our basin when we started. And as Elise had mentioned earlier, really in like 2020 and 2021, it just became a hot topic of conversation. And so now we're seeing a ton of momentum behind it. And so it's still, we had 3 NRCS run SNOTEL sites in our basin that did have soil moisture sensors installed. And we also had some Colorado State University run QuagMet stations that measure soil moisture on irrigated agricultural lands. But none of that data was incorporated, and it's still not incorporated into our water supply forecasting. And so throughout this project, we're really excited to have completed phase 1, in which I'll talk a little bit more detail here in a moment. We're now in phase 2, and this past year we installed 2 additional stations in addition to the first station that we installed in 2022. And we're planning on installing six more stations in the next 2 years. And the next slide shows our funding partners, for which this would not be possible without. We received our initial funding from the Upper Yampa Water Conservancy District, who is a wonderful water agency that we have here in the Yampa Valley, and they really supported and funded phase 1 of this project, which launched it. And then in 2023, we received additional funding from the Upper Yampa Water Conservancy District, along with new funding from the Colorado Water Conservation Board's Water Plan Grant, along with the Colorado River District's Community Funding Partnership. And that funding was for phase 2 of this project. And so we're really excited with that funding to deploy a substantial amount of stations in this next phase. And then on our next slide, I will highlight in phase 1 kind of how we initially started our site selection. We did this through a basin analysis, and this process involved talking to stakeholders to identify needs, and the stakeholders included Upper Yampa Water Conservancy District, the Colorado Basin River Forecast Center, among others. We assessed where observational gaps were present in our watershed, so what monitoring networks were already out there, what are they measuring, and where are they physically located in our watershed. We also evaluated atmospheric drivers of change in the basin, and we conducted a K-means cluster analysis using precipitation, elevation, slope, aspect, and vegetation to understand how these land type characteristics drive physical and climate variability, and then of course impact soil moisture. And the cluster analysis was really useful in that it divided up the watershed based on multiple different hydroclimate characteristics, and it ensures that we're sampling a diverse set of regions within our watershed. And I want to highlight that throughout this project, we have sought to be really scientifically rigorous and strategic in our analysis, and it has provided us with a strong foundation for where these stations ought to be placed throughout the watershed. And you'll see our cluster analysis there on the right.
So once our cluster analysis was completed as part of phase 1, we developed a site selection prioritization process based on the feedback and discussion within the team, as well as input from our stakeholders. So this allowed us to determine target areas for the stations in the network. So in addition to that cluster analysis, some additional considerations for our stations were to ensure that the stations were distributed across elevations as well as spatially throughout the watershed. We also prioritized the Colorado Basin River Forecast Center's mid-elevation zone, which they highlighted had limited observations and sort of increasing variability in snowpack. We also made sure to prioritize a few stations in the high-producing snowpack regions of the watershed based on feedback and interest from our project partners and stakeholders at the Upper Yampa Water Conservancy District. And then, as Maddie already mentioned, we made sure that we looked at the existing network of climate observations in the basin, for example, the NRCS Snow Towel network, and spoke with them to ensure that our efforts were complementary to their existing and planned networks. So this is an example of what one of our soil moisture stations looks like. On the right here, we have an annotated picture of our first installation, Ski, which is located above Stagecoach Reservoir. Our soil moisture stations measure a suite of hydroclimate variables to capture sort of a comprehensive picture of the conditions at the site location. So our stations include soil moisture and soil temperature at 6 steps, starting at 2 inches and all the way down to 40 inches in the soil column. We also measure air temp and relative humidity, solar radiation, liquid precipitation, wind speed and direction, air pressure, and snow depth. So I have the different data frequency, and then all of that data is telemetered out every hour, so it's available in near real time. And then after some of our initial conversations with the local Drought County National Forest, we additionally added fuel temperature and fuel moisture to our sites to ensure that these stations had increased benefits for their operations as well. We also make sure that all of our data is publicly available and hosted on multiple different sites so that it's increasing its usability and availability to a variety of different audiences. Here's some initial data from our ski station, which was installed in 2021. So soil observations typically need a little time to settle, so these are just some preliminary plots here. So on the left, we have soil moisture at our ski station, and it's color coded by depth, with the warmer colors being closer to the surface and the cooler colors being more at depth. And we're looking here at the early part of the water year, some of the fall storms that came by the site. So we have plotted precipitation as well. And you can see that as these fall storms are kind of rolling through, we're seeing unexpected influence on the shallow soil moisture as these storms kind of come through the basin. On the right here, we have plotted the snow depth measurements in gray from the ski station, as well as a nearby stream gauge above Stagecoach Reservoir. This is a USGS stream gauge, and we're plotting discharge here. So you can see the ski station measured a good amount of snowpack in this year. And then as we move into spring runoff, we see an increase in discharge at that local USGS stream gauge, which is pretty consistent with the other SNOTEL stations in the region. So our results appear to be as expected, which is great. I also included a QR scan here that goes to our data, and as well as there's a few links at the bottom here. So we're hoping this is just the first year of many years of data at these sites. An increasing period of record at these stations will only increase the utility of the data. So at present, the existing hydrologic models are not necessarily able to incorporate soil moisture data, but the next generation of those models are likely to be able to. However, when that happens, they're going to need a long period of record in order for the data to be usable. So having the installation of these sites and the recording of these observations now will only make the data more useful in the future. And then we can also look at longer term patterns and changes within the basin due to climate change and other factors as well. So we're hopeful that these stations will continue to collect more and more data and prove more and more useful through time. The YBASIN project team is also excited to continue to expand the network in the coming years, as Maddie already mentioned. We've chosen our stations based on the site selection process and are in the process of permitting the remaining stations. So this is a representation of our planned and existing sites within the basin. I have a hypsometry plot here. That's the black line. So this just shows what percentage of the basin is above or below these elevations. So this dashed line here shows this is 50% of the whole watershed will be below this elevation. And then I also just boxed out the CBF RC sort of mid-elevation regions. The blue circles here are the existing SNOTEL sites. Many of these do not currently have soil moisture, but we're working with NRCS with support from the Upper Yampa Water Conservancy District to install soil moisture sensors at all of the sites within the Upper Yampa in the coming years. The purple circles here are existing YBASIN sites, and then the blue circles are the existing SNOTEL sites. So you can see that we do have a large portion of our stations within the CBRFC target elevation. So 5 of our stations will be there. And we also have 4 stations in the lower 50% of the watershed. Both of those were sort of a gap with the existing SNOTEL sites. So we're excited to expand into some new elevational regions. On the right, I just have some pictures of our recent installations, which have included a diverse group of staff, faculty, and students from CW3E, YBASIN, and Colorado Mountain College. You can go to the next slide, Marina. Thank you.
I think it would be Els who's showing. El, can you, there you go.
Oh, there we go. Thank you.
Great. And then as mentioned throughout our presentation today, we just wanted to highlight that this project is highly collaborative. We continue to host large group partner project meetings where we work with our partners, including NRCS, the Colorado Basin River Forecast Center, among others, to coordinate on our efforts. And we have really appreciated our partnership with the Aspen Global Change Institute, which we've been partnering with them since about 2020. And throughout that partnership, we also host 2 research interns in each basin every summer. And so we're really excited to have that collaboration as well. With additional funding from the Upper Yampa Water Conservancy District, we also assisted the NRCS snow survey team to identify and enhance their SNOTEL stations in our watershed by adding soil moisture sensors to ones that did not have them. And we helped them install some of those sensors. So we're really excited and grateful for these partners, and we look forward to continuing our efforts together. And with that, we can go to the next slide, and we'll just close by saying thank you so much, and we look forward to answering your questions. Elle and my contact information is listed there on the slide. And then we have one more slide after this, just some of our key takeaways. We think that having a diverse collaborative partnership really increases the capabilities of our network and allows us to leverage the work that's already being done. It's really important to be rigorous and strategic with the site selection so that we're making sure that we're addressing our goals and capturing the soil moisture variability that we have in our basin for the benefit of our stakeholders. And with that, I think we will turn it back to you.
Great. Thank you, everybody. Okay, well, those are really two interesting presentations, and we've got a number of questions, so let's start into those. Again, if you have any other questions that you want to add in, please put them in the question box, and then I'll be able to read them. So let's see. We had a couple questions for the first presentation, kind of on the research side. Elise, how is runoff efficiency calculated for your low elevation sites with ephemeral snowpack that accumulates, ablates multiple times? What is the denominator in R equals Q over snowpack? The questioner is working on ways to think about this in the Southwest. Elise, you may need to unmute.
Okay, can you hear me?
Yes, we can.
Sorry, it took me a second to find my unmute button. So the question was, how are we calculating runoff efficiency? Is that correct?
Correct. For the low elevation sites with ephemeral snowpack that accumulates, ablates multiple times. Yeah, go ahead.
You know, we actually didn't really account for the fact that it is an ephemeral snowpack, and that's why I was shocked we had such a good relationship, that we had just used the same method across all of them as using November monthly average soil moisture as our antecedent soil moisture. And then for snowpack, we were using modeled precipitation throughout the winter. So we were not using snowpack specific to those sites. I think going forward, I would encourage someone to use a method different than ours if they're dealing with sites with ephemeral snowpack, so that that's accounted for more closely. For example, one of the things we've discussed internally is using a different date. November is sort of the date that's the date used within these communities, but I think it would make more sense to maybe look at January, February, or even March for those lower elevation sites. I hope that maybe answers the question a little bit.
Yeah, and if the questioner has a follow-on, feel free to add that again to the question box. But one more for you, but I think maybe also YBASIN could speak to this. Curious whether Iron looked at groundwater and the interaction with soil moisture at all.
That's a great question. We have not been able to look at groundwater yet, but I think that that's going to be a really critical component to add in.
Great. And YBASIN, did you all want to speak on the groundwater topic?
Sure. I'll just say that this is not something that we have dived into too much depth yet. We did initially look at a station that had some groundwater interactions, and so we started thinking about it a bit more, but we haven't researched this too much. But I think it's a great topic for us to further dive into. And I'll pass it to Elle if she has any additions there. But
no, I think that was what I was going to say, Maddie. Thank you.
Okay, got a couple questions relating to where you placed your sensors, and I think this is a whatever eternal interest to those of us doing soil moisture monitoring. So one of them is soil sensor depths at predetermined depths. So excuse me, soil sensors that predetermined depths would seem not to reliably capture moisture in the saprolite zone bedrock interface, which may transmit large subsurface runoff. So is there any plans to capture that? Let me roll in another question. So that's one about dealing with that bedrock interface and how that might affect things. And then the other one, again, related, how does one ensure that soil moisture samples are representative of the watershed with regards to soil disturbance, which includes soil compaction, et cetera? So maybe, Elle, do you want to take that one first? And Madison? This question of depths, and then also maybe impaction or other effects on the soil.
Yeah, so our depths, the reason we're using, 2, 4, 10 all the way up to 20 inches depth is to match sort of existing observations done by NOAA as well as NRCS partners that we've talked to. So I understand that it might not be perfect, but it does allow for a good consistency across our network and to be able to compare a little bit more easily to some of the other networks that exist within the network, within the area. And then in terms, Marina, what was your second question? Sorry.
Related to a soil disturbance, which can soil compaction, et cetera.
Yeah, we do our best for the YBASIN network to put the sites in undisturbed soil as best we can. So a lot of our sites are in sort of forested regions, especially in the high elevation, to hopefully mitigate some of the impact from soil disturbance. We're not necessarily putting them in agricultural regions like some other networks are more focused on. Maddie, do you have anything else to add there?
Nope.
Okay, Elise, anything you want to comment on?
Yeah.
Go ahead.
It's definitely dealing with that heterogeneity and how do you represent it is a major question. I would say something about our basin is that between 70 and 80% of our lands in this area are actually public lands. So I think we have probably a pretty high percent of soils that are not necessarily disturbed in a way that it might be if they were a more developed area. I don't know if that helps answer that question a bit.
Yeah, okay. Well, we're almost out of time. We actually are formally out of time. If folks have to drop off, feel free, but I do want to sneak in one more question for our presenters. Notice that soil temperature and moisture, air time, et cetera, were collected every 2 minutes, yet the data were summarized in daily, 15 minutes for snow depth. Any reason for collecting more frequently versus what you report? And I know this is, again, a question that's kind of common across soil moisture networks. So thoughts on that? Go ahead, Al, maybe we'll start with YBASIN.
Yeah, so we collect higher resolution data in order to make sure that we're capturing like the full time period in case there are large spikes in precipitation or changes that are occurring. And then it gets sent out hourly just because we're trying not to bog down the communication systems that we're using. The 15-minute data is for snow depth. We've just found, based on experience as well as talking to others, that having a higher rate of snow depth sampling doesn't necessarily, it just leads to a lot of noise within the data that you have to clean and filter out. So that's sort of the reasoning behind that. There's other networks that have been using 2-minute sampling frequency as well. So we just did that. And then we offer 2-minute as well as hourly data on our website. So depending on the application and the use that you want to use the data for, it's there.
Great. Elise, did you want to comment for Iran? I'm sorry, you might have already mentioned this, but I don't remember your frequency.
We're
And
every 20 minutes across all sensors, and we are happy to share data at that resolution. Right now, we're a little behind on manually updating the ISMN and Quasi where we share our data, but we're hoping to soon, in June, have a live site where anyone can download the raw data at whatever interval they want.
Okay, great. Well, we really have reached the top of the hour and the end of our time. We do have a few questions that I'm sorry I couldn't get to, but really appreciate everybody's engagement. And we have recorded this session, and we will be sending out to all the registrants the link to the webinar recap. So look out for that. And again, just want to thank our presenters today for these very exciting projects in the Colorado River Basin. Look forward to hearing more from you all as you keep going. So thanks everyone for joining us today.